back to Math 155, section 9.4. In this lecture video, I'm going to show you um, something called the installment loans. All right. So, installment loan simply means we will make a monthly payment, okay, for so many months or so many years until the loan is paid off. All right. So this is considered as a close-ended because there's an actual definite due date for the entire loan will pay off, such as car payments. Car payment is considered as an installment loan. Once you purchase the car and finance it, then every month you got to pay, okay, your monthly payment, okay, because when you borrow money to buy that car and it's for 60 months, then that car got to be paid off in 60 months. Okay, so when you miss a payment, okay, when you miss a payment, there are things that the finance company can help you, but as far as extending beyond the 60 months, for example, okay, they might have a hard time trying to do that because original agreement is everything got to be paid off, okay, within within so much amount of time. So installment loan is a fixed installment loan. That means there's a definite due date. Now, before I begin to show you this, show you how to do this example, there is something I want to go ahead and to talk about real quick, which we will do this quite a bit here in a minute. All right, what does it mean to pay off? All right, to pay off your debt. To pay off your debt is simply referring to the total amount that you have paid. So the way how we actually figure out what's the total amount have paid in order to pay off the loan, the debt, is take the monthly payment. I'm going to use the word PMT since we'll be using a lot of that. You take whatever payments you were supposed to make times the time it takes. Okay, whether it's monthly, okay, for 40 a month, 60 month, whatever the time is, okay, take the payment times the total amount of time you need to make your payments, okay, then this, after you multiply, whatever the answer is the total amount of time, total amount of money you have paid. Therefore, since you're doing, if you're doing a monthly payment, once you paid every single month, that means you have paid off, okay, what you borrowed. So inside this amount, okay, the payoff amount, it has your principal, what you borrowed, okay, the money you actually borrowed, plus the interest. So in order to extract the interest, okay, we will have to take the payoff amount or whatever the total amount of money you paid, subtract off the principal. Okay, we'll do example like that here. All right, now this very first one is actually using this particular formula. This particular formula is finding the amount of a monthly payment, okay, on a fixed installment loan. P is the principal amount of money borrowed. R is your APR. N is the number of payment per year. Okay, be very careful down here. This is a negative N times T. T is still representing the number of years. Okay. So to make things a little bit easier, let's convert these months into years. So Arden wants to buy a new refrigerator. The refrigerator costs $2,150, so that's my P. Arden decides to finance the refrigerator for 24 months. So 24 months, all right, in terms of years, that will be 2 years, right? With an APR of 12.5%, so that's my R. Determine Arden's monthly payments. Okay, so this problem want me to find the monthly payment. So PMT, monthly payment. I borrowed 2150 times R is 0.125 divided by the number of payments. whole thing divided by brackets 1 minus parenthesis 1 plus 0.125 divided by 12, and it's 12 because I'm doing this monthly. I'm paying this monthly, raising to the negative. N is 12 times T. Time is 2 years. All right, bracket. All right, let's punch it in real quick. So again, this exponent, I'm gonna put them in the blue parenthesis. All right. So let's see what our monthly payment is. So parenthesis 2150 times 0.125 divided by 12. Close parenthesis for the numerator divided by, all right, bracket, open a parenthesis for bracket, 1 minus, open parenthesis for the 1 plus 0.125 divided by 12. Close parenthesis, exponents, raising to, open the blue parenthesis, negative 12 times 2, close the blue parenthesis and close the brackets. All right, my answer, $101.71. All right, that will be Arden's monthly payment. Okay, that's how we estimate the monthly payment. All right, let's try another one. Okay, consider a credit card with a balance of $6,000 and an APR of 15.99 in order to pay off the balance in 3 years. So what the monthly payment should you need? All right, so this problem is different than the one we mentioned in 9.4 objective A, because this formula was used to find the number of payments. Right now, in this scenario, what is going on is we have a $6,000 balance and we decided to pay it off in 3 years. All right, so we are not going to use this credit card anymore, but doesn't matter. Excuse me. Doesn't matter whether we use the credit card or not continuously, as long as I owe money as long as I owe this balance, my interest is constantly being charged monthly. Okay, so it's not just take the number of payment divide into 6,000, because you're gonna think about all the interest that's actually occurring, all right, during the time you're trying to pay it off. That's why this formula comes in. Now this particular example is, okay, if I want to pay everything off in 3 years, this is my APR, this is my balance, what should my monthly payment be in order for me to pay it off? So in a way, we are treating this like an installment loan, okay, because we're trying to pay it off, this entire balance. So what should our monthly payment be? So my monthly payment is going to be parentheses 6,000 times, okay, 0.1599 divided by 12, paying this monthly. What monthly payment should I need to make? So I'm doing this 12 months in a year, divided by brackets, 1 minus parentheses 1 plus 0.1599 divided by 12, raised into the negative. N is 12 times T, which is 3 years. Alrighty. So of course, on the credit card, as you can see on the credit card statement, it does have, okay, if you make no additional charges and each month you pay $60, so here is an extra line that the government require credit card company to put in, is saying, okay, if you will make this monthly payment, you can pay it off in 3 years. So basically what we are doing right now is if we make no additional charges on our $6,000 balance and we want to pay it off in 3 years, okay, what is my estimated monthly payment? Okay, that's what we're trying to do here for this example. So let's see. 6,000 times 0.1599 divided by 12, close parenthesis, divided by open bracket, 1 minus open parenthesis, 1 plus 0.1599 divided by 12, close parenthesis, exponent, open another blue parenthesis for the exponent. Let the calculator figure that out for me. Negative 12 times 3. Close the blue, close the brackets. My monthly payment will be $210.91. Alright, so this will be my monthly payment if I decided not to put any more charges on the balance, and this is what I will need to make, alright, to pay off the entire balance in 3 years. Alrighty, let's try another one. Okay, now this one is a little bit more work, so let me show you this problem. Now, Lynette bought a new car for $27,000. She paid 20% down payment. So down payment here means she actually gonna pay some cash. Okay, so she's not gonna borrow the entire $27,000. So let's figure that out real quick. So what is her P? How much money would she finance? Well, if she's gonna put 20% down, well, hold on a second. All right, what's her down payment? Her down payment got to be 27,000 times 20%, right? Part is equal to percent times the whole. Okay, 27,000 times by 0.2. Her down payment will be $5,400. Alright, so her P, which is what she will finance, will be 27,000 minus 5,400. So that will tell me what she will finance. Subtract 5,400, which is 21,600. Alright, remember now, she only gonna finance for 21,000, not 27,000, okay? All right, and she's going to put $5,400 down payment. All right, so she paid a 20% down payment and financed the remaining balance, which is a 21,600 for 48 months. So 48 months is, in terms of year, that will be 4 years. All right, so that's my T. This is my P. Write it down. All right, with an APR of 4.1%. Now, assume she make monthly payments. Determine the total cost of Lynette's car. All right. So basically, in order to find her total cost, all right. In order to find her total cost, see, when she pay off the car, that means whatever her monthly payment is times the 48 months. So the payment here is by the month. If I times by 48 months, all right, take the monthly payment times by 48. If she pay this payment, whatever this payment is going to be, if she pay for 48 times, that means she have paid off the car. Now, but this question is asking for what's her total cost. How much money did she actually put into this car? Well, she is going to put whatever the monthly payment is times by 48 plus, before she even financed this car, she already put down the down payment, so which is $5,400. So if we add back the down payment, then we can figure out what is her total cost. So the first thing I need to find, which is the first thing I need to find is her monthly payment. All right, so let's use this formula. because since we are dealing with an installment loan here, so P times R over N. So my payment, all right, finance 21,600 times my APR is 0.041 divided by 12, whole thing over bracket 1 minus parenthesis 1 plus 0.041 divided by 12, whole thing raised into a negative. N is 12 times the time in year, which is 4. Alrighty. Now, let's see what her monthly payment. Assuming she made a monthly payment, so we got to have this monthly payment first. Then we can times by the duration of the loan, which is 48 months. The reason why I convert 48 months into 4 years is for the formula right up here. Alrighty, so let's check it out. And I'm gonna do this separately here in a minute. Excuse me. 0.041 divided by 12 divided by bracket 1 minus open parenthesis 1 plus 0.041 divided by 12. Alright, close parenthesis, exponent, open the blue, negative 12 times 4. Close the blue, close the bracket. Her monthly payment is going to be estimated at $488.67. $488.67. Alright, so this is her monthly payment. Alright, so let me do this, okay? Total cost. Alright, if she is going to make $488.67 times, alright, she do this every month for the next 48 months. So once she paid the last payment, she has paid off the car. But as far as the total amount of money she actually spent on the car, we need to add back the down payments, $5,400. Okay, so let me do this in 2 separate steps for you, okay? 488.67 times 48 months. Once a month for 48 months. All right, $23,456. Once she paid all that, she had paid off the car. Now, as far as how much money did she actually spend on the car, we need to add back the down payment because she actually spent a down payment in order to get the 4.1% APR financing. So if you add the down payment back, she has spent total $28,856.16. Alright, so that will be the total amount of money she spent on the car. Alrighty, that's how you figured out this particular example. Alright, so I'm gonna let this particular video to become the part 1 of my installment loan because the next 3 example is actually quite couple of them is actually quite long. Alrighty, so that will conclude this part 1 of installment loan. Thank you for watching.